Hey everybody, this is 7.5. So this is the last section in chapter 7 that we're going to do. The first part of what we're doing is rewriting equations a little bit. It is a little complex. We're going to step through it a couple of times though, you'll get it. And then we're going to talk more about the vertex of a parabola because it's a special thing. All right, so what we have is this form that we saw the other day in the last video in 7.4 that really helps us to look at a quadratic function and graph it. But most of the time we get a function that's not in that form. So we have to figure out how to get from one form to the other. And it's sort of along the lines of completing the square, actually. So here are the steps to do this. We want to take x squared plus 8x plus 13 and make it into a times x minus h squared plus k. The way we do that is with the following steps. Okay, ready? First, we're going to regroup. There's no rule against it. So we're going to take x squared plus 8x plus 13. And I'm going to put x squared plus 8x in parentheses. Okay, I'm going to put the 13 to the outside. That's what's going to slowly become my k. But now I have to take x squared plus 8x, and I need to make it into this. And that's where the whole completing the square comes in, because now I want to complete that square. Okay, so I'm going to take, this is still b, half of b squared. So half of 8 squared is, half of 8 is 4, 4 squared is 16, okay? What I'm going to do with that is here's the thing, I need to keep the value of my expression the same. So I want to add a 16 inside the parentheses. If I want to do that, I then have to also subtract it on the outside. Okay, I have to make a net 0 there, which is what I just did. All right, so now the inside is a perfect square. And I can rewrite it. Remember, half of 8 is 4, so that's really what I'm going to use as my perfect square. So I get x plus 4 squared, which is what this is factored. Negative 16 plus 13 is minus 3. And there is the form I'm looking for. The a comes in a second. We'll see an example of that. Now, this is something I can graph, right? So if I wanted to graph it, so now it's f of x is x plus 4 squared minus 3. Now I know some stuff, right? I know that the vertex is at -4, -3. I know the axis goes through the x value. Axis of symmetry at x equals -4. I know my graph opens up because that's a positive in front of the parentheses. I know the minimum, if I think about it, the minimum y value, it's got a minimum at y equals -3. Okay, basically, here's my graph. So let's see, -4, 1, 2, 3, -3. There it is. It's going to look terrible because I'm drawing with my finger. But here's my graph, okay? That's what we need to be able to do. It's a lot easier to graph this than that. I need a big old chart and ugh. All right, so let's do that whole thing again. We're going to write it in that new form. Then we're going to identify the parts. Same steps as before. So I have x squared plus 8x plus 1. First, I'm going to regroup. Okay. Then I'm going to complete the square. So half 8 squared, same I had before, right? It's 4 squared is 16. Okay, so I'm going to add that inside and outside. x squared plus 8x plus 16. I'm going to add a net 0, so minus 16, that plus 1's still out there. Okay? No, it's a minus 1, sorry. Look at my equation. The inside is going to be x plus 4 squared. Minus 16 minus 1 is minus 17. Now we have our function written the way we want it. So now we have to tell them some stuff. They want to know the vertex. Well, I know the vertex is at -4, -17. The axis of symmetry goes through the x value, so it's at x equals -4. It opens up, so I need the minimum value is at here, y equals -17. I'm finished. All right, so not so bad. There are some times where you're going to have one additional step, and here it is. It's going to be your second step, okay? So the first step is still going to be the same. I'm going to take my -2x squared plus 12x minus 16. And the first thing I'm going to do is regroup, okay? The step here that matters is in order to complete the square, I can't have a coefficient in front of x squared. I have to factor out that -2. So I'm going to pull it out. I'm going to pull it out to the front. Oops, and then I'm going to forget what I'm writing. So I'm going to take it out to the front. I get -2. That leaves me x squared minus 6x minus 16. Okay? Now I'm going to complete the square inside my parentheses, just like I've been doing. So half of -6 squared, half of -6 is -3, -3 squared is 9. So I'm going to keep this. I'm going to add 9 inside the parentheses. And here's the trick. Now think about this. If I were to distribute the 2 to the 9, I'd have an 18. So that 9 is actually being doubled by this 2 outside the parentheses. So I also have to multiply it by 2, -2, by the same value here and here. Okay, otherwise I didn't create a 0. I need this guy to create the same value. This guy is really 9 times -2. Okay, and then I have minus 16. Okay, so -2 stays there. This is going to be x minus 3 squared. I'm going to use that middle value. -2 times -9 is -18, or sorry, positive 18, minus 16. All right, so combine these two. My final answer is going to be -2, x minus 3 squared plus 2. Now we're in the right form. Hooray! Okay, so I'm going to rewrite it here so that we can see it. It's f of x is -2, x plus, nope. Me and my pluses and my minuses today, forgive me. Minus 3 squared plus 2. Okay, so now we need to know the vertex, the axis of symmetry, and the rest. The vertex is at +3, +2. The axis of symmetry goes through that x value, so axis is at x equals 3. This guy opens down, right? Because the 2 in front of here is negative. So it's got a maximum value. The maximum value is there. So max at y equals 2. All right. The x and y intercepts now I need to find. Now they want extra things. Well, we know how to find those. Okay? What I can do is sort of go back to my practice of factoring. To find the x-intercepts, I solve for x. Okay, so I get, I'm going to set it equal to 0. Okay, and I'm going to factor. And I can do that. I'm going to factor out a -2, make that x squared minus 6x plus 8. Okay, well, I've had lots of practice factoring at this point, so I know that's going to be x minus 4, x minus 2. Okay, this guy divides away basically. So 0 equals x minus 4 and 0 equals x minus 2. So x equals 4, x equals 2. Those are my two x-intercepts. I have one at 4, 0, and I have one at 2, 0. Y-intercepts means I put 0 in for x, and I see what happens. So f of 0 is negative 2 times 0 squared plus 12 times 0 plus, oh no, minus, nuts, minus 16. Well, that's a 0, that's a 0. The answer is minus 16. So the y-intercept is at 0, negative 16. That's it. Okay. Now, if I'm feeling crazy and I can get my slides to move down, which I can't seem to do, I can graph this. Well, I know it's got a y-intercept at way down at negative 16. I don't have that on my graph. It's got an x-intercept at 4, 0 and a y-x-intercept at 2, 0. And the vertex was at 3, 2, right? 1, 2, 3, right here. Oh, fantastic. And this is going to go way, 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 way down here before it crosses the y-axis. Now I have a graph. Woohoo! All right, this is one for you to try. It is worth working through this. Okay, I will tell you the following things. First, in its properly written form, it is negative x minus 3 squared plus 4. Okay, vertex at 3, 4, max at 4, axis at x equals 3. Pardon me. It's got x-intercepts at 5, 0, and 1, 0. It's got a y-intercept at 0 and negative 5. So you should be able to make the graph. This is the information you should come up to when you're done. Okay, so one of the ways that we can find the vertex of a graph is by going through these steps. We get the vertex, but we got a lot of information about it. It's a really good thing to be able to do. Sometimes, though, all we really need is the vertex. And when that is the case, we have a way to do that, okay? So what we do is we can find negative b over 2a for a given equation. And then we can find the function value at whatever that number is. That is the vertex. I will show you what I mean. So I want to use the vertex formula, which is what this is called, to do this. So a, b, c, right? I want to do negative b over 2a. Well, negative b is positive 2, negative, negative 2, right? A is 1, so 2 times 1. So I get 4 over 2, which is the same as 2. Okay? So in my vertex, the first number is going to be 2. The second number is f of 2. Okay? What that means is I'm going to put in 2 where I see x. So 2 squared minus 2 times 2 plus 5. Well, 2 squared is 4 minus 4 plus 5 gives me 5. Okay, so the vertex is 2, 5. Uh-oh, did I do the math right? Nope, I didn't. Look at me. Where did I get the 4 from, friends? I don't know. This was supposed to be a 2. I don't know why it became a 4. It was negative, negative 2. So that should have been 2 over 2. Oh boy. And that should be a 1. Let's try that again. You see what it meant to be, though. Let's see. Ay, ay, ay. So 1 squared times negative 2 minus 1 plus 5. Whew. 1 squared is 1, minus 2 plus 5 gets me 4. Oh my good gravy. That's what happens when I look over at my notes and go, oh gosh, that doesn't match. I see mistakes just like you make them. That's why I do them twice. All right, so the vertex here is 1, 4. We're going to do another one just to make everybody feel better. How's that sound? Oh, wait, x and y intercepts. Okay, so when we go to do this, we now need to find the x and y intercepts. We do that the same way we've been doing it. Okay, whatever way we do it, we solve for x. And honestly, this one you look at and I go like, I can't really factor that. So I want to use the quadratic formula, which is fine. But first I'm going to find the discriminant. Let me see what kind of answers I get. So it's b squared minus 4ac. So b squared is negative 2 squared minus 4 times 1 times 5. Well, it's 4 minus 20. It's negative 16. When the discriminant is less than 0, it tells me there's only imaginary answers. And that means there's going to be no x-intercepts. So I don't have to do the factoring here because there isn't anything to factor. To find the y-intercepts, I'm going to put 0 in for x. So 0 squared minus 2 times 0 plus 5, 0, 0, and 5. So the y-intercept is at 0, 5. And somehow I wrote y. Excuse me. Okay. So then we have to graph this. Well, we know the vertex is at 1 and 4. Over 1, up, 1, 2, 3, 4. I know that it's got to face up because this x squared is positive. I know that it's got a y-intercept at 0 and 5. Oh, look at that. That's what my graph is going to look like. There we go. So let's do one more of the vertex formula just so we can not make silly mistakes. So here's one similar kind of thing. Vertex formula is b, negative b over 2a. And then f of negative b over 2a. So negative b over 2a is negative 4 over 2 times 1, right? Negative 4 over 2 times 1 is negative 4 over 2 is 2. F of 2 is going to be, let's see, 2 squared plus 4 times 2 plus 6. 2 squared plus 4 times 2 times 6. Well, it's it was a negative 2. Negative 2 squared. So let's see, that's 4 minus 8 plus 6. 4 minus 8 plus 6 would get me, that's 10 minus 8 is 2. All right, so my vertex is at negative 2, 2. The x and y intercepts, I'm going to check again. I'm just going to use the discriminant for x first. So let's see, b squared minus 4ac. b squared is 4 squared minus 4 times 1 times 6. 16 minus 24. That's going to be negative 8. So these are imaginary. No x-intercepts. Y-intercept, I'm just going to put in f of 0. So I get 0 squared plus 4 times 0 plus 6. It's going to be at 0, 6. Okay, from there, you guys can make that graph. I have faith in you. All right? All right. There are some applications that we can use with the vertex. So let's do that. So the crew from Extravaganza Entertainment launches fireworks at an angle of 60 degrees from horizontal. The height of one fireworks display can be approximated given this formula, where h of t is measured in feet, this is the height, and t is in seconds. So first I want to know how long it will take the fireworks to reach their maximum height. If you think about a firework, right, we launch it off. That max height is way up here. What's that max height? It's the vertex. Okay, so I want to know, do I want to know the x value or the y value there? Well, really, I want to know the y value, don't I? The max height is how far up the x-axis it is. Okay, so we need to find the vertex. Well, negative b over 2a is the x value. So negative b, let's see, it's 128 square root of 3, yikes, negative, over 2 times negative 16. Fun. You have a calculator. You can calculate that. This comes out to be approximately 6.9. Okay, so then it's f of 6.9. So negative 16 times 6.9 squared plus 128 square root of 3 times 6.9. Again, you have a calculator. You can figure this out. It's approximately 768. So my vertex is at 6.9, 768. That's the height, basically. Oh, sorry, we said how long first. Well, that's the time. Okay. Maximum height at the vertex. So this is the second question I'm doing right now. Good Lord. So this is the maximum height up here, 6.9 and 7.68. The other question is how long it will take us to get there. Well, so we want to know the height. That's the x, that's the y value, right? The x value is the time. This is how far it's traveling for that height. It's going to be 6.9 seconds. Okay. All right, let's try another one. Oh, that's the second question. Same idea here. Object launched in the air at the velocity of 48 feet per second from the top of the building 288 feet high. Find the height of the object after t seconds is in this formula. Find the time and then the height. Same thing, we're going to do the vertex, negative b over 2a. This is going to be the time. And then f of negative b over 2a is the height. Okay, so let's see. Negative b is negative 48 over 2 times negative 16. Well, that's going to be what, c? It's about 1.5, 1.5. You have a calculator, right? All right, f of 1.5 is like negative 16 times 1.5 squared plus 48 times 1.5 plus 288. That is somewhere in the neighborhood of 324. So there's our vertex. Their rocket launched, rocket falls back down. Here's how long it took us to get there. Here's how high it went. Makes sense that it took a little less time to get up there because it's a rocket. It's going really fast. It's got a much higher velocity than a firework would have. All right. This is the last thing in this section. This is a little bit of an outlier here. It is going to come up in ALEKS though, so let's see how we can do this. Essentially, it's not fun. What you're going to do is start with ax squared plus bx plus c, okay? We're going to put in some different values here. So we're going to put in each x value, okay? So I have y equals, sorry. So at 1, negative 1, basically I get negative 1 equals a times 1 squared is just a plus b times 1 is just b plus c, okay? At negative 1, negative 5, I get negative 1 equals a times 5 squared is 25a. Oh, no, I did my x's and y's backwards, pardon me. This is going to be negative 5. Negative 1 squared is just 1a. B times 1, negative 1 is minus b plus c. And then at 2, 4, what we're going to do is we're going to put in the 4 equals a times 2 squared is 4a plus b times 2 is, 2b plus c. So now I have 1, 2, 3 equations. What I can do is solve for those and get the values of a, b, and c and put them back into my equation. This sounds insane. You're really only going to have to do it a couple of times in ALEKS. So just do your best. This is not a huge thing in this section. So I'm going to solve, let's see. Remember when you did systems of equations in 095? Either that or it's been a long time. So we can solve systems by substitution or by elimination. Here I can get rid of that. So I get -6 equals a 2a plus 2c, right? Yes. Okay. Actually, you know what? That's what we get here. So then I can see if I can eliminate anything else anywhere else. The other thing I could have done here is that I could have used that equation differently. A plus b plus c, -5, a minus b plus c. I could multiply that by -1. I would get a 5 here, but -a, positive b, -c. And that's going to let me, so I'm going to pretend that's not here, and eliminate both of those. So I get 4 equals 2b divided by 2, b equals 2. So now I've got a value for b. Now all of a sudden I have to just solve for a c somewhere. So I can also, let's see, I'm going to use this guy, 4 equals 4a plus 2b plus c. And this guy, I'm going to multiply that guy by, oh, no, I'm going to use that one, by -1, okay? Not -1. How did I do that the second time? I did. I used 5, oh, there it is, times a minus b plus c. Okay, I'm going to multiply this guy by -1. So I get -4 equals -4a minus 2b minus c. Okay, so I get 1. Oh no, that's a -5, I right. -9 equals -3a minus 3b, and the c's go away. Then I know what the value of b is, right? So I can put in the 2 here, a -2 for b. So I get -9 equals -3a plus 6 minus 6. Now I'm running out of room. Extend page. Okay. So I get negative. I feel like I have a sign wrong somewhere. Do I? Are you looking? Minus 3b. Yep, I do. That should be a -6 plus 6. Oh. So I get -3 equals 3 -3a divided by -3. A equals -1. So now all I have to do is go back to this equation over here. This is crazy, isn't it? This is where you shut off the video. -1 plus 2 plus c. So I get -1 equals 1. No, it's a positive 1. I have to go. Equals 3 plus c minus 3. C equals -4. So now I know that guy, and that guy. So my equation through those points is 1x squared plus 2x minus 4. It's a lot of work to get there. You really probably will need to do it in ALEKS like once, and if it's not the end of the world, it's not the end of the world. Don't stress over this one. It's in here to sort of follow through if you would like, but it's not going to show up on a test. So do your best. I will see you guys in the review and in the next section.